All right, you might have noticed that we are going a little bit out of order. That is on purpose. So today we are going to be talking about section 9.4, volume of prisms and cylinders. Our objective is to find volume of prisms and cylinders. So on our warm-ups, we are asked for 1 through 4 about this solid on the side. What is the name of that solid? A rectangular prism. We also need to know the area of the base. What shape is the base? What shape is the base? A rectangle. That's why it's called a rectangular prism. So we are finding the area of a rectangle. What do? Length times width, or we call it base times height. So yes, in this case we're taking 4 times 5, and what do we get? 20, good, centimeters squared. What is the height of the solid? 10 centimeters, good.
Based on height.
So notice that the height of our base is not the same thing as talking about the height of the solid. When we're talking about the base, we're focusing only on this rectangle at the bottom. But when we talk about the height of the solid overall, we are then talking about this 10 on the side there, how tall it is. Finally, on number 4, they are asking about the perimeter of the base. How do we find perimeter? Add up what? Good. We add up all the sides of the base. So we're going to take 4 plus 5 plus 4 plus 5. Okay, we have to do all of the sides. So 4 plus 5 plus 4 plus 5 gives me 18 centimeters. Would those be squared? No, because it's not area. All right, on the bottom 4 questions, we are asked for the name of this new solid. It's a cylinder. Even though it is not a polyhedron, we can still identify it as a cylinder. What is the area of the base? In order to know that, I need to know what shape the base is. It's a what? A circle. So our base is a circle, top and bottom, we can see that, circle. So how do we find the area of a circle? So for the area of that circle, we need pi times r. What's our radius? 5 squared. What do we get approximately? 78.5?
Yeah.
Units?
Squared.
What squared? Feet squared. All right, what about the height of this solid? 7 feet. And the circumference, Jordan had already given us the formula for that. For circumference, we take 2 times pi times our radius of 5. And what do we get? 31.4. Units would be feet. Are they squared? No, they are not. All right, we've got some definitions that we need. First, volume. I think most of us are at least roughly familiar with the idea of volume. It's the number of cubic units needed to fill a container. You've got a separate line for examples of units. So inches cubed, centimeters cubed, feet cubed, etc. So pretty much any kind of distance that we could have, we could cube it to have a volume. Real life examples would include things like amount of soda in a can. Really any sort of item that would be held inside of a container. That would be an example of volume.
Why do you click 3 easy?
That's a good question. Why do we think?
That's
Cubic units, which means we have how many different dimensions that we're working with? 3 dimensions. A prism we talked about yesterday. A solid figure with 2 polygons that are called the bases. Then you'll have to jump down to volume of a prism. That box down there, we'll get to a cylinder in a minute. The volume of a prism is the area of a base times the height. So they give you a line for the capital B. Well, they give you the formula. V equals capital B times H. That's the overall formula. So I would make sure I have that written down. Capital B, we need to write down. Capital B stands for the area of one base. So usually little b is like the length of a base. Capital B is talking about the area of one base. So for example, the area of a rectangle, the area of a triangle. The H is going to be, or the height, is the distance between the bases. Okay, so on these, we are finding the volume of the prisms. So our volume equation on these is the area of a base times the height of the prism. So on number 1, what shape does my base have? It's a rectangle. So to find capital B, the area of one of my bases, what am I going to do? How am I going to find the area of the base on number 1? Multiply what?
10 and 6.
Good. Multiply 6 times 10. So remember, that's like little b times h, base times height of a rectangle. So capital B equals 60. What are my units? Inches. Remember, capital B stands for area of a base, so our inches get squared. Then we need to know what little h is. H is the height of the prism. What is that? 9 inches. So then to find our volume, we are going to multiply those two things together. Our volume is going to be 60 inches squared times 9 inches. What are we going to get? 540. And now that we've got volume, our inches are cubed. Good. So we had squared and then another one from the 9. So that bumps it up to being cubed. Just like area was always squared, volume's always going to be cubed. Questions about number 1? All right, on number 2. What shape does my base have? No. A triangle. This is a triangular prism. That means my base is a triangle. Now I understand that might seem a little strange because it's not sitting on a triangle, right? It's sitting on a rectangle. But our bases, we've got 2 congruent bases. Those are triangles. How do I find the area of a triangle? Remember, capital B stands for the area of a base. So if my bases are triangles, I'm trying to find the area of a triangle. Base times height?
Yeah.
1/2 base times height for a triangle.
Man.
We gotta remember these, or have our blue formula sheets from that chapter where we did area handy. So if I'm looking at this triangle, I need to take 1/2 times the base times the height. Now the base of this triangle, little b, would be this bottom edge here, but they didn't label it right there. So what is the little base of this triangle?
14.
Good, 14. We have to take it from the other triangle. They are congruent. So 14 is the little base of the triangle. How tall is just the triangle? 9. Good. So when we calculate capital B, the area of the base, 1/2 of 14 is 7 times 9.
63.
63. My units are
Centimeters.
centimeters
Squared. Cube.
squared.
Oh, yeah, we know area.
Yep, capital B stands for area. So now we've got the area of the base. We need to know the height, which is the distance between the bases. What is it?
9.
Oh,
Wait, what was the question?
what is the height of the prism? 13. Remember, the height of the prism is how far or what the distance is between the bases. So if I'm focusing on these triangles as my bases, 13 is going to be my height. To calculate my volume, I have to take capital B times H. So this is the easy part. Should have put my units there. 63 times 13. What does that give me?
2,119.
I don't get you heard. Say it loud.
2,119.
Do we agree with that? That seems a little big to me. What'd you get, Connor?
819.
What'd you get?
819.
819. Anybody agree with that?
For 60 based on 13, that's so low. Where did I get that from? I'm just saying it should be a
Do we have questions about how we calculated that?
Nope.
Are we sure?
Yep.
All right, on number 3, what is the shape of my base?
That's a rectangle prism. Am I right?
It's a triangular prism again. We got 2 triangles, the rest of them are rectangles. So a triangular prism, it's going to be very similar to what we just did on number 2. To find capital B, we have to take 1/2 times the little base of the triangle. What's the base of the triangle? Bottom side of my triangle.
15.
Not 15. 5 times the height of that triangle. How tall is the triangle? This one's a little bit tricky. It's the 6. Remember, the height has to make a right angle. So if we take 1/2 times 5 times 6, what do we get? 15 centimeters squared. Then we need to know what the height of the prism is. So the distance between my bases. What is it? 15 centimeters. So to calculate the volume, we take capital B times H. 15 times 15, what do we get? 225. My units are centimeters cubed. Questions on 3? Are we ready for number 4?
Yes.
4 is a little bit easier. Anytime it's a rectangular prism, it's always going to be a little bit easier. How do we find capital B? What shape is our base? It's a rectangle. To find the area of a rectangle, we take base times height. So you get to choose if your base is going to be this rectangle kind of facing front here. Do we want to use that as our base, or do we want to use the bottom one? First one? Okay. It doesn't really matter. You just kind of have to choose. I would maybe highlight which one you're using as your base, kind of like I did with the triangles. Highlight which two you're using as your base. So if we take 12 times 15 to get our area of that base, what do we get? 180 inches squared, because it's area. What's the height of that prism? It's 20. So that's why I said highlight whatever you're using as your base. Because if these two are our bases, the front and the back this time, then your height is the distance between them, and that would be the side that's 20. So that is my height, the 20. Yep, so to find the volume, we're going to take 180 times 20, and what do we get? 3,600. Our units would be inches cubed. So that's 3,600, 3,600 inches cubed for our volume. Another type of prism is a cylinder. A cylinder is a 3D shape with circular bases. So if you want to flip back to the front to fill that in. Cylinder is a 3D shape with circular bases. All right, then you'll need to flip back to that second page because we have to fill in the formula for the volume of a cylinder. The volume of a cylinder, much like the volume for the other prisms, is the area of the base times the height. But this time our bases are circles, so to calculate their area, we have to take pi r squared and then multiply it by the height of the prism or the cylinder. So right before example 5 in your notes, there's a little box for volume of a cylinder, and I would put that formula in that box. All right, on number 5. Again, I like cylinders because our bases always have what shape?
Circle.
A circle. So when we go to find the volume, we can just use pi r squared times h. So I can just go ahead and plug things in right away. I'll explain what they mean about the exact and the approximate in just a minute. So our volume equals pi. You can, if you really want to, use 3.14 for pi. I always find it easier to just use the button on my calculator. What is my r, or my radius? 8. So the radius always gets squared times the height is 12. Remember, the height is still the distance between your bases. If your bases are the circles, the distance between them is that 12. All right, what is 8 squared? 64 times 12. So when they say to find the exact volume of it, that means we're not multiplying pi out. So we would just multiply 64 times 12. So what is just 64 times 12? Connor? Oh. Okay.
768.
768, and so that's before we multiply the pi to it. So if we are looking for exact, we're leaving the pi as the symbol pi. Our units would still be centimeters cubed because we're still finding volume, so it's still units cubed. For the approximate, that's where we actually multiply out the pi. So now if we were to take 768 and multiply it by pi, what do we get?
I was going to say 2,412.7. All right.
Still centimeters cubed. All right, on number 6, again, a cylinder means that we are going to take pi times our radius squared times the height. What is our radius on number 6? 9. And our height is 18. So we have pi times, what's 9 squared? 81 times 18. So if you want the approximate and you just want to punch this in your calculator, pi times 81 times 18, what do we get for our volume?
You get 1,458.
Pi.
1,458. Did you multiply the pi to it or not?
No,
Not yet. So you like the exact?
I did that for the first one.
You get 4,580.2.
You get
Okay.
45, 80 something.
I already said that.
Yep. So you choose whichever one you want. Either one of them should have units on it, though. What units?
Centimeter. Yeah.
Cube.
What cubed?
I mean,
Inches cubed. Okay.
I'm looking at the wrong one.
So whichever one you prefer, but it should have inches cubed on it.
So that's all we gotta do.
That's it. All right. Let's go ahead and do number 7. 7 is a little bit different. Why is 7 different? Good. They gave you a diameter, which is not extremely useful up front because our formula needs the radius.
So we gotta find it.
So we need to find the radius. How do we find the radius from the diameter? Take half of the diameter, which, yes, somebody already said was 10.
You have to show
You need to show your work for the volume. You don't have to show me 20 divided by 2. I'm confident many of you can do that in your head. What about our height? It's 11. All right, so our volume is equal to pi times 10 squared is 100 times 11. So if you want to just leave it as 1100 pi inches, oh, we should have had consistent units. So I would change one of those to be inches.
It has the same unit.
Yeah, they should be the same. Otherwise, you can't really do it. Inches cubed. Or if you want, you can multiply it out. So
3,455.7.
3,455.